Good afternoon, dear students. We are discussing the Unit 5 in 10th physics lessons. Acoustics is going on. Already two of our staffs took classes related to acoustics. I am going to take the third part. They started with the introduction and then description about the sound waves, nature of sound waves, and then they discussed about the velocity of sound waves and what are the factors to which the velocity of sound waves depends upon. And then in the second session you might have studied about the reflection of sound waves taking place in denser and rarer medium, also in plane and curved surfaces. Also you have discussed about echoes. Now we are going to discuss about a very important fundamental related to sound, which is Doppler effect and its applications. It's a very useful one, which is applicable in day-to-day activities, day-to-day lifestyle, especially in the field of medicine. Doppler effect plays a very key role in astrophysics also. These are all the ideas which we are going to discuss today. Please kindly follow our video, go through it carefully and learn the fundamentals effectively so that it will be helpful for you in your future. As we are in a state of curfew due to corona, we could not able to interact straight away to you. So we are taking classes to you through online. So kindly follow and learn well. Thank you. Already you have discussed about so many fundamentals related to sound waves. Now we shall speak about Doppler effect, which is a very important phenomenon, which is a very important thing which happens in our day-to-day life. Doppler, you might have heard about Doppler scans, you might have heard about the ultrasound scans, which are also based on the fundamentals of Doppler effect. This is a very important fundamental. We shall see some of the important terms related to the ones what we are going to discuss, and then we shall get into Doppler effect. First one, we always used to speak about a thing called pitch. Pitch refers to how high or low a sound is. How high or low a sound is, which also depends upon the frequency. Which also depends upon the frequency. If I say, as you know, frequency is number of waves per second. If the number of waves per second is less, then the wave is said to be a low pitch sound, because the frequency is low. If the frequency of the sound wave is high, then we can say this is a high pitch sound, because frequency is high. Frequency is high. So depending upon the frequency, we can mention the pitch. Pitch here refers to frequency. So it refers to how high or low a sound is. Then next thing, we are going to speak about source and a listener. What is source and what is listener? The one which produces sound waves is said to be a source, and the person or some other detecting device which is receiving the sound waves, detecting the sound waves, is called a listener. So I can say a siren in a police vehicle, or a siren in an ambulance, or a whistle blown by a train, are examples of sources. And then listener, ordinary a person who is standing on the platform or on the roadside, or any detecting device is said to be a listener, right? So a person, for example, is considered to be a listener. So you used to use the term source and listener, which is very important in Doppler effect. And the next thing, we should speak about a relative motion. What is meant by relative motion? When do you say an object is said to be under rest? When do we say an object is said to be under motion? How come? It can be explained. Whenever you relate the objects with some reference, then we can easily specify whether the object is under rest or object is said to be under motion. If a building is there, as long as you see the building is staying there itself, then that means the object is said to be under rest. How come you say the building is staying on at the same position or at the same place? You will be comparing with some other reference there, some tamarind tree which is there beside the building. With reference to the tamarind tree, the building is always there, so the object is said to be under rest. So what exactly you are doing is you are relating the position of the building with respect to the position of the tree. So the tree is said to be under rest. If suppose a car is there standing beside a pole, after a few minutes the car is said to be moving away from the pole, which means the pole is stationary, pole is said to be under rest. With reference to the pole, the car is moving somewhere. So the car is said to be moving with respect to the pole. So you always used to compare the position of one object with respect to the position of the other object in order to explain whether the object is said to be under rest or the object is said to be under motion. That is termed relative motion. That is termed relative motion. So two things are important: rest and motion. They are all made, they are all explained on the basis of some reference. Some reference. With respect to some object, or with respect to some reference points, we will be explaining about the position of the other objects. Whether they are said to be under rest or under motion is determined only by some reference frames. We used to call it frame of reference. In higher classes, you will be studying about frame of references. Here we are not introducing frame of reference, we are simply referring here as some object, reference object. With respect to some reference object, these objects, the other objects are said to be either under rest or under motion, depending upon the comparison. If one object is said to be remaining stationary at a particular point, another object is said to be remaining at the same position forever, then the object is said to be under rest. If the same object is moving with respect to the first reference point, then the object is said to be moving, right? So the objects are moving or under rest depends upon some reference. Reference is always required. Based on this idea, or with these ideas, we are going to speak about the Doppler effect now. In order to speak about or to understand Doppler effect, we shall go on with the simple examples and explanations. You are standing on or you are standing beside a road talking to your friend. A car is moving. A car is coming from there, far off distance. He is blowing. The driver is blowing the horn of a car. He is blowing the whistle of the car continuously, and he is moving. When he is at a far off distance, you can hear a low sound. As the car approaches towards you, the sound whose pitch increases, means whose frequency increases. Then as the car passes by, right at the instant where the car passes by, the sound frequency of the sound produced by the whistle or the horn produced, frequency of the sound produced by the horn, and the frequency of the sound listened by you are the same. As the car moves away from you, then the frequency of the sound goes on decreasing and finally it vanishes. So we can say the sound listened by you is said to be decreasing in frequency, but the sound produced by the source, which is nothing but the horn, is always the same. But the one what we received, the listener, being a listener, what we received is quite different. This is what we call Doppler effect, because this was first observed and explained by Christian Doppler, an Austrian mathematician and physicist. He explained how it happens and why it happens, why there is a change in the frequency. We can define what is Doppler effect. Whenever there is a relative motion between the source and the listener, the frequency of the sound waves listened by the listener is different from the frequency of the sound waves produced by the original source. This is called Doppler effect. I would like to recall once again the definition here. Whenever there is a relative motion between the source and the listener, whenever there is a relative motion between the source and the listener. Then the frequency of the sound heard by the listener is different from the frequency or the original frequency of the sound produced by the source. Sound is producing some frequency, I can call it nu. And the frequency of the sound listened by, or this is the original frequency. If nu L or nu naught or nu prime, whatever you wish, you can have. Nu prime is the frequency of sound heard by listener, then nu prime will not be same as that of nu. If this condition exists, then there is a Doppler effect. If nu prime is same as that of nu, then there is no Doppler effect. Here there is a Doppler effect. There is no Doppler effect. There is no Doppler effect. When the frequency of the sound heard by the listener and the frequency of the sound produced by the source are the same, then there is no Doppler effect. If the frequency of the sound heard by the listener is not the same as that of the frequency of the sound heard by the or produced by the sound source, then there is a Doppler effect. This frequency may increase or decrease when compared to the frequency of the sound produced by the source. That we can check with the different cases. When do we say there will be a relative motion? What are the different possibilities to bring out this relative motion? That we shall discuss, and then we shall go on to the next idea. Possibilities of relative motion. One, listener is moving away or towards the source. Second one, source is moving away or towards the listener. Third one, both the source and the listener are moving towards or away from each other. And fourth one, the movement of medium with respect to the source and the listener. Source and the listener. We shall have some simple examples. Listener is moving away or towards the source. Let us say a car is a driver in a car is blowing horn by keeping the car in idle condition. You are at a far off distance, you are hearing the sound, and you are moving towards the car which is at rest. You are the listener. A listener is moving away or towards the source. You are moving towards the source. Now, you are very close to the car and you don't want to hear the sound which is said to be annoying to you. So, you are moving away from the sounding source. So, you are the listener. Either you can move towards the source or you can move away from the source. And then second one, source is moving away or towards the listener. You are sitting on a stone bench. Some car is moving, approaching towards you. So your source is moving towards you, and it is passing by and is receding away from you. Here, as it is approaching towards you, you will be hearing high frequency. As it is receding away from you, you will be hearing low frequency. So a source is moving towards you or away from you. You are the listener and the source is moving or away from you. And third one, both the source and the listener are moving towards each other, either towards or away from each other. A car is approaching towards you and you are also moving towards the car. In this case, car is the source, you are the listener, you both are approaching each other, you are approaching towards each other. And car is moving away from you, you are also moving away from the car. You people are traveling in the opposite directions. Then we can say you people are receding away from each other. Both the source and the listener are moving away from each other. And then the movement of medium with respect to the source and the listener. I can consider the source and the listener are at rest. There is an intervening medium. Wind is there, air is there. If air is blowing from the source towards the listener, because we can say whatever the space we are living in, it is filled with air, as you know. So if the air is blowing from the source to the listener, that is one idea. If the air is blowing from the listener towards the source, that is another idea. That is also playing an important role in the change in the frequency of sound waves listened by the listener. So that is also considered the movement of medium with respect to the source and the listener. This is also an important idea. In order to have a clear picture about this Doppler effect, in order to understand how the frequency changes are taking place, we shall have a simple animation view here. So here is the thing that is emitting waves. It could be a fire truck emitting sound. It could be a star emitting light. It could be a duck creating ripples on the waves. Those are all waves and they are look like something like this. When the thing that is emitting waves moves, in the direction it's moving, the wavefront bunch up and behind it they spread out. If our object is moving towards a stationary observer, these bunched up waves are observed at high frequencies. And if the object is moving away from a stationary observer, the waves are spreading out at a lower frequency. So that is Doppler effect. The apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer is called Doppler effect. So let's say you are standing in the middle of a road, that's you, and a car drives past you very fast. As it does so, it honks its horn because you are standing in the middle of the road. The horn to you might sound something like this. So it starts at a high pitch and moves to a lower pitch. Even though from the driver's perspective, the horn is playing the same pitch the entire time. So what's going on? As the vehicle is coming towards you, the sound waves that is emitting bunches up, and so you are delivered with a high frequency, which you interpret as high pitch. And that when the vehicle passes you and is moving away from you, the sound waves spread out, and so you hear them at a lower frequency, so a lower pitch. So that's how the Doppler effect works with sound. It's also observed in case of light waves. Even Doppler effect can be observed in case of light waves also. A star which is emitting light waves is observed by an observer on the earth. If the star moves towards the observer, there will be a bunching of light waves taking place as it approaches towards the observer. So what happens is that there is an increase in frequency of light waves. This increase in frequency of light waves will show a shift towards the violet end of the spectrum. Because as you know, a spectrum has 7 different colors from violet to red. WebGR, in short we used to call WebGR. So as the star approaches towards the listener, then what will happen is that the frequency goes on increasing. As the frequency increases, this increase in frequency will shift towards the increase in frequency of the visible spectrum. So it tends to move towards the violet end. So the star will not have the same color. As the star moves towards the listener, the star appears to be changing its color. If it is said to be in green in color, as it moves towards you, then the green color changes to blue, then indigo, then violet. So we used to call it violet shift. If suppose the same star is moving away from the listener, then what will happen is that the waves which are produced by the star will be spreading out like this. So what happens is that as the star moves past the listener, it is moving away from the listener, then the frequency of the light waves increases. As the frequency of the light waves decreases. If frequency of light waves decreases, then the color of the star will shift towards the low frequency region, which is nothing but red. We used to call it red shift. So from the color of the light obtained from the star, we can identify whether the star is moving towards us or moving away from us. Based on this idea, the Big Bang theory has been explained that when stars are observed by the astronomers, they found that the stars are producing redshift, which indicates that the stars are moving away from each other, which means the universe is expanding. So the expansion of universe is explained on the basis of Doppler effect. Also, we can say, we can identify binary stars. We may not identify the stars, binary stars with our naked eye, because the stars do not show that they are doublets. But with a telescope, we can easily identify that the two stars are separate, but they appear to be a single star for our naked eye. If you observe the twin stars, one star will be moving towards us because they are rotating about a common center of mass. So one star will be moving towards us and another star will be moving away from us. So this can be identified with the help of this Doppler shift. So Doppler shift in light is also very important in determining the or in explaining the positions of stars, in explaining about the universe. As we saw the different possibilities which brings out relative motion, we shall now consider, for our simplicity, for calculation simplicity, we are considering the medium between the source and the listener is said to be at rest. So I can say the velocity of the medium is 0. By considering this idea, we are going to proceed further. Let us say S be the source, L be the listener, Vs is the velocity of source and Vl is the velocity of listener. Now, if we consider, or in this particular case, we also have to consider that the source and the listener are moving along the same straight line. Let us say this is a car, this is a listener or observer. We shall say both their motion are along the same straight line. So that is also an important consideration which we have to make. Now we can have a simple case here that the source and the listener are moving towards each other. This is the condition where the source and the listener are moving towards each other. Source and the listener are moving towards each other. In this particular case, we can say if n is the frequency of the source and n prime is the frequency of sound observed by listener, then I can say n prime is greater than n, which means this n prime is termed apparent frequency. N prime is apparent frequency. What is that apparent frequency called? In Tamil we can say apparent means velipadayana. So when you stand outside, as the car passes by, you can hear the sound whose frequency is increasing and is same as that of the original frequency. As the car passes by, the frequency of the sound decreases. This is happening as it is. It is obvious. So this frequency, what you have listened, is termed apparent frequency. This apparent frequency is greater than the original frequency in this particular case. When the source and the listener are moving towards each other. When the source and the listener are moving towards each other, the apparent frequency is greater than the original frequency. As I mentioned, n is the frequency of the source and n prime is the frequency of the sound listened by the or observed by the listener. Then we can bring out a relation connecting these two frequencies. N prime is equal to some multiplying factor into n, which is v plus vl divided by v minus of vs. V plus vl divided by v minus of vs, where v is the velocity of sound in a given medium. We are speaking about three velocities. One, the velocity of sound in a given medium, and two, vl, it is the velocity of velocity of the listener, and vs is the velocity of the sounding source. As I mentioned earlier, n is the frequency of original frequency of the sounding source, n prime is the apparent frequency. Once again I express here, n is the original frequency of sound source, n prime is the apparent frequency. From this expression, we can say the numerator is v plus vl and denominator is v minus vl. If v is supposed to be 330 meter per second, if the velocity of the listener is considered to be some 50 meter per second, velocity of the source is also considered to be 50 meter per second, then the frequency of the original frequency of the sounding source is let us say some 250 hertz. Then what will happen? If you substitute all these values, then we can say apparent frequency n prime is equal to 330 plus 50 divided by 330 minus of 50 into 250. If you look at the case here, the numerator goes as 380, denominator goes as 280 into 250. This is n prime. So numerator is more, denominator is less. Obviously n prime will be greater than n. N prime will be greater than n. So a simple calculation. Approximately 9 4s are 36, 7 4s are 28. So if you cancel this out, 9 point something will come. If for a rough calculation I am doing, if you cancel this out, this is almost 35. So 315 hertz approximately, not exactly, approximately. If you just look at the case here, the original frequency of the sounding source is 250 hertz and the apparent frequency is 315 hertz. So what exactly happens is that the apparent frequency increases when compared to the original frequency, so n prime is greater than n. So what we can explain from here is that as the source is moving and the listener is also moving, as they are approaching towards each other, then the listener will hear the frequency of the sound wave, which is greater than that of the frequency of the original sound. There are various cases which are related to Doppler effect, because as I have mentioned already, there are various possibilities which brings out relative motions. So a source is moving towards observer, or observer is moving towards a source. Source is moving away from observer, or observer is moving away from the source. There are various possibilities. We are going to list out 8 different possibilities, which brings out the different kinds of relative motion, and correspondingly what are the apparent frequencies heard by the listener. That's what we are going to discuss now. Before getting into that, I am going to make out a simple assumption here. A general expression to determine the apparent frequency can be given as n prime is equal to V minus of VL divided by V minus of Vs into n. As I have mentioned earlier, the velocity of the medium is taken to be 0, and n is the original frequency of the sound source, n prime is the apparent frequency, V is the velocity of sound in a given medium, VL is the velocity of the listener, Vs is the velocity of the source. This is the general expression. General expression with which we are going to bring out the results here. In order to study about the different values of apparent frequencies for different relative motions, we need to apply some sign convention here. Sign convention. In order to understand the sign convention, I can give out a simple example here. A car is moving, which is the sounding source. A listener is there who is standing at a far off distance. If the driver blows the horn or honks the horn, then the sound waves will be traveling in all directions. We have to consider the sound propagating along the, or sound propagating towards the listener. Sound propagating towards the listener. So this one is cancelled. If sound is produced, sound will be spreading out in all directions. As water waves are spreading out when you throw a stone in a pond, water waves will be spreading out in the form of ripples. We are considering the propagation of sound waves towards the listener. Right. Now, here we consider this as the direction in which the sound wave is propagating. Direction in which the sound wave is propagating. So this direction denotes the direction of sound. Then car is moving towards the listener or away from the listener, whatever we can consider. The movement of the source is taken as Vs. Movement of the source is taken as Vs. And the movement of the listener is taken as VL. If the source or listener moves along the direction of propagation of sound, then Vs or VL is positive. Vs or VL is positive. If sound wave is propagating along this direction, source is also moving along the same direction as that of propagation of sound, then Vs must be taken positive. If the observer or listener is also moving along the same direction as that of the propagation of sound, then VL is also positive. If the source or listener moves opposite to the direction of propagation of sound, then Vs or VL is negative. This is very important. This is not in your textbook. You just note down the general expression and then you use this sign convention so that all the applications will be very easy. What you have to consider is that you should know the direction of propagation of sound first. You have to identify the direction of propagation of sound. Second thing, in what direction the source is moving. Third one, in what direction the listener is moving. If the source is moving along the direction as that of propagation of sound, then the source whose sign is taken, Vs, the velocity of sound, must be taken positive. If the listener is moving along the same direction as that of the propagation of sound waves, then the listener whose velocity must be taken positive. So plus VL plus Vs, like that. Then if the source is moving opposite to the propagation of sound waves, which means car is moving along this direction, but sound is reaching the listener. So sound is moving along one direction, car is moving in the opposite direction, so the velocity of sound must be taken negative. If the listener is moving towards the car, he is following the car, so what will happen? He is moving in a direction opposite to the propagation of sound waves, so VL is also negative. So these sign conventions are very important. Sign conventions are very important. If the source and the listener moves along the direction of propagation of sound waves, then the velocity of source and the velocity of listener are taken positive. If the source or listener moves opposite to the direction of propagation of sound waves, then the velocity of source and velocity of listener is negative. Now we shall speak about the 8 different cases in Doppler effect. One, we can say, before speaking about this, we can list out position of the source and the listener. Then correspondingly we have to write the note. And third one, we can speak about the apparent frequency, expression for apparent frequency. First case, you can write both source S and listener L are moving. Both source and listener are moving. In this particular case, the source and listener are moving towards each other. Source and the listener are moving, and they are moving towards each other. I can draw a diagram for this. So I can put a box for the source, and I can draw a simple line diagram for the listener. This is the source and this one is a listener. Source and the listener are moving towards each other. As the source produces sound waves, sound wave is propagating towards the listener, because we have to consider the direction of propagation of sound towards the listener, because who is listening the sound? The listener is listening the sound. So sound must move towards the listener. That is very important. So sound waves are moving, propagating. Source is moving along the same direction as that of sound. So Vs is taken positive. And then we can say velocity of the listener here is moving opposite to the direction of propagation of sound. So VL is negative. Sound is the reference here. With respect to the direction of propagation of sound, source is moving along the direction of sound waves, so Vs, velocity of sound, is positive. I am applying the sign convention. Then to the direction of sound waves, propagation of sound waves, listener is moving opposite to the sound waves, so listener whose velocity is given negative, minus VL. I am using the general expression there, which is n prime is equal to V minus of VL divided by V minus of Vs into n. Now I have to apply sign convention in this particular case. VL must be taken plus VL, Vs must be taken, Vs must be taken plus Vs, and VL must be taken minus VL. If you substitute the sign convention in this expression, what will you get? N prime is equal to V minus of VL is minus, so minus VL divided by V minus of Vs, because Vs is positive, into n. So minus into minus is plus. So V plus VL divided by V minus of Vs into n. This is n prime. So n prime is equal to V plus VL divided by V minus of Vs into n. Numerator is sum of two velocities. Denominator is difference of two velocities. So n prime must be greater than n. So I can say in the note that apparent frequency is greater than actual frequency of sound source. Apparent frequency is greater than actual frequency of sound source. This idea is very simple. Apparent frequency is greater than actual frequency of sound source. Here I mentioned velocity of the sound is taken positive, velocity of the listener is taken negative. So expression for apparent frequency can be written as n prime is equal to V plus Vs divided by V minus of, V plus VL divided by V minus of Vs into n. This is how this expression comes. So if you use this general expression and apply the sign convention, the expression for apparent frequencies will be very simple. Getting the apparent expression for apparent frequencies will be very simple. And you can give out the note also. The apparent frequency is greater than the actual frequency. Apparent frequency is greater than actual frequency. Velocity of the sound is positive, and the velocity of, I can say here, velocity of sound is positive, and the velocity of the listener is negative. Velocity of the listener is negative. When you apply the sign convention, you will get the expression for the apparent frequency. And in the note, I can also write the distance between the source and the listener decreases as they are approaching each other. The distance decreases. So what will happen? The frequency of the waves gets compressed, so that will produce a high frequency, so you will get a high pitch. So apparent frequency is greater than actual frequency. This is the first case. So when the source and the listener are moving towards each other, then the apparent frequency will be greater than the actual frequency, because the distance between the source and the listener decreases. As I mentioned you, the general expression n prime is equal to V minus VL by V minus of Vs into n. Vs is positive because the source is moving along the direction of propagation of sound and listener is moving opposite to the direction of propagation of sound. So n prime is equal to V minus of minus VL divided by V minus of plus Vs into n. So the expression will be n prime equals V plus VL divided by V minus of Vs into n. That's the first case. In the second case, both the source and the listener are moving away from each other. They are moving away from each other. Source is moving away from the listener. Listener is also moving away. They are receding away from each other. If car is moving along this direction, it blows a horn, it honks a horn, but the sound waves will be propagating towards the listener. We have to consider that direction alone. This is the propagation of sound waves. So sound is propagating along this direction. Listener is also moving away from the source. Now, by applying sign convention, I can say if the source is moving opposite to the direction of sound waves, then Vs is negative. But the listener is moving along the direction of propagation of sound waves. So VL is taken positive. So Vs is negative. So minus Vs. And VL is positive, so plus VL. By applying the sign convention in this general expression, I will have n prime is equal to V minus of plus VL divided by V minus of minus Vs into n. So this is equal to V minus of VL divided by V plus Vs into n. This is n prime. So apparent frequency equals V minus of VL by V plus Vs into n. Numerator is less than denominator because numerator is difference of two velocities. Denominator is sum of two velocities. So n prime is less than n. So I can write apparent frequency is less than actual frequency. See this symbol? Apparent frequency is less than actual frequency. Vs has got the sign convention negative, Vl has got the sign convention positive, and we can say distance between the source and the listener increases. Distance between the source and the listener increases. So the expression for apparent frequency is n prime is equal to V minus of Vl divided by V plus of Vs into n. V minus of Vl divided by V plus Vs into n. This is the second case. So when the source and the listener are moving away from each other, source is moving opposite to the direction of propagation of sound waves, so Vs is negative. Listener is moving in the direction of propagation of sound waves, so Vl is positive. By applying the sign convention in the general expression, I am getting n prime equals V minus of Vl divided by V plus Vs into n. Notice apparent frequency is less than actual frequency. You will be listening a low frequency, low pitch sound than the original frequency, because the distance between the source and the listener increases. They are moving away from each other. In the third case, both the source and the listener are moving one behind the other. One behind the other. I can say source is following listener. Source is following listener. So I can say this is the source, this is the propagation of sound, direction of propagation of sound. Listener is this one. Listener is moving along this direction, in one direction. Source is following the listener. Source is following the listener. So by applying sign convention here, we can say Vs is along the same direction of propagation of sound, so Vs is positive. Vl is, our listener is also along the same direction of propagation of sound, so Vl is also positive. So when you apply the sign convention in general expression, n prime is equal to V minus of Vl divided by V minus of Vs into n, where n prime apparent frequency will be V, as Vl is positive and Vs is also positive, we will be getting the same result. Vl is positive, Vs is positive, so V minus of plus Vl divided by V minus of plus Vs into n. So apparent frequency will be n prime is equal to V minus of Vl divided by V minus of Vs into n. What do you understand from this? The apparent frequency depends upon the velocity of listener and the velocity of the source. So we can say here in this note, we can say apparent frequency depends upon velocity of the listener and the velocity of the source. Depends upon the velocity of the listener and velocity of the source. In all our discussions, we always consider the velocity of listener as well as the velocity of source are less than the velocity of sound, less than the velocity of sound in the given medium. This is our consideration always. Velocity of the listener and velocity of source are always less than the velocity of the sound waves. So the apparent frequency depends upon the velocity of the listener and velocity of the source. Apparent frequency whose expression is n prime equals V minus Vl by V minus Vs into n. In the fourth case, both the source and listener are moving one behind the other, but in this case, listener follows the source. Listener follows the source. I can give you an example here. Listener follows the source. A car is moving in front of me. I am also traveling in another car, so I am the listener. A car which is moving in front of me is blowing a horn, so that is the sounding source. So car is moving in front of me. It is moving in one direction. I am following the car moving in front of me. So I am listening the sound waves produced by the car. That is the case which we are discussing here. Listener follows the sound. Both are moving along the same direction, one behind the other, but listener follows the source. I am following the source. So the diagram can be represented like this. Sounding source is moving along one direction. Listener is following the sounding source. He is also moving along the same direction, but the propagation of sound waves must be considered, because he is blowing the horn, he is honking the horn that produces sound waves. The sound waves are reaching the listener, so the direction of propagation of sound must be taken along this particular direction. So source is moving opposite to the direction of propagation of sound, so Vs is negative. Listener is moving in a direction opposite to the propagation of sound, so VL is also negative. In the general expression, VL is applied negative, Vs is also taken negative, minus of minus will become plus. So n prime is V plus VL divided by V plus Vs into n. So I can give out the expression V plus VL by V plus Vs into n. So what will happen? Apparent frequency once again depends upon VL and Vs. Depends upon VL and Vs. But in this case also, the velocity of listener and velocity of source are always maintained less than the velocity of the sound waves. This is the fourth case. So if both source and listener are moving one behind the other, but listener follows the source, then the source and the listener are moving in a direction opposite to the propagation of sound waves. So Vs is negative, VL is taken negative, so the apparent frequency is V plus VL divided by V plus Vs into n. So apparent frequency depends upon the velocities of listener and source. In the fifth case, source is stationary. Listener is moving towards the source. Listener is moving towards the source. So in the diagram, I can show you source is stationary. It is producing sound waves. So this is the direction of propagation of sound. As the source is stationary, it is not moving, velocity of sound is 0. Velocity of sound is 0 as it is not moving. Listener is moving towards the source. Listener is moving towards the source. As he is moving opposite to the direction of propagation of sound, VL is taken negative. VL is taken negative. What will be the expression for apparent frequency here? N prime is equal to V minus of VL divided by V minus of Vs into n. N prime is equal to, as I have mentioned, velocity of the sounding source is 0. It is not moving, it is at rest, it is stationary. So V minus of minus VL, which has become plus VL, I have applied the negative sign here, minus of, I can show you, V minus of minus VL divided by V minus of 0 into n. So apparent frequency N prime is equal to V plus VL divided by V into n. As the numerator is the sum of two velocities and denominator is the velocity of the sound alone, N prime will be greater than n. So I can say here apparent frequency is greater than actual frequency. Apparent frequency is greater than actual frequency. What does it mean? As the listener moves towards the sounding source, stationary sounding source, he will be receiving high frequencies as he is approaching towards the source. So apparent frequency or the frequency of the sound listened by the listener goes on increasing when compared to the original frequency of the sounding source. So apparent frequency is greater than the actual frequency, and the expression for apparent frequency N prime is equal to V plus VL divided by V into n. V plus VL divided by V into n. This is the fifth case. So when the source is stationary, the listener is moving towards the source, then by applying sign convention, the velocity of sounding source is 0. Propagation of sound takes place along this direction. Velocity of listener is negative because he is moving towards the source. By applying the sign convention, I am getting N prime equals V plus VL divided by V into n. Apparent frequency is greater than actual frequency. So as the listener moves towards the sounding source, he will be receiving a high pitched sound. Then sixth case. Sixth case. Source is stationary, but listener is moving, I can say, away from the source. Listener is moving away from the source. See this one? I have made a change. Listener is moving away from the source. In this diagram, this region exists as it is. Instead of this arrowhead, I have to mark this arrowhead because listener is moving away from the source. He is moving away from the source. I can say a car is producing sound. and I am moving away from the car. So what will happen? Obviously the sound received by me will be, or the frequency of the sound received by me will be decreasing continuously, and it will vanish if I move far away from the sounding source. That we are going to bring out in terms of expression. If the listener is moving away from the source, then as the source is stationary, Vs is 0. As the listener is moving away from the sounding source, also he is moving along the direction of propagation of sound, so VL is positive. So in the general expression, if VL is positive, V minus of plus VL divided by V minus of 0. So V minus of plus VL is nothing but V minus VL itself. So N prime equals V minus of VL by V into N. So N prime is less than N because numerator is the difference of two velocities. Obviously from V some velocity is subtracted. So numerator is less, denominator is more, N prime is less than N. So I can write the expression for apparent frequency. N prime is equal to V minus of VL divided by V into N. What about the note here? Apparent frequency is less than the actual frequency. See this one? Apparent frequency is less than actual frequency. The frequency of the sound heard by the listener is less than the frequency of the original sound. This is the sixth case. Seventh case is that listener is at rest. Source is moving towards listener. Source is moving towards listener. The diagram I can show, this is the source, sound, the direction of propagation of sound. P of S is nothing but propagation of sound. Source is S, listener is this one, listener is at rest. He is at rest, so velocity of listener is 0. Source is moving towards, I have taken the condition towards. Source is moving towards the listener. So Vs is traveling along the direction of propagation of sound, so Vs is taken positive. Vs is taken positive. Velocity of the source is along the direction of propagation of sound, so Vs is positive. Both are traveling along the same direction. So what will be the value of apparent frequency? I am using the general expression. N prime equals V minus of VL divided by V minus of Vs into N. This is equal to velocity of the listener is 0, so it is simply V divided by velocity of the source is positive, so V minus of plus Vs into N. So this will be N prime is equal to V divided by V minus Vs into N. N prime equals V divided by V minus of Vs into N. If you look at this expression, the denominator is the difference of two velocities. So denominator is less, numerator is more. So N prime is greater than N. N prime is greater than N. As you know, N prime is apparent frequency, N is the actual frequency, N prime will be greater than N. This is simple mathematics. If you look at this case, velocity of the sound wave is approximately, you can consider 330 meters per second. If the velocity of the sounding source is 30 meters per second, so 330 minus 30 will be 300 only. 330 divided by 300 will be greater than 1. So N prime will be greater than N. That's the meaning. So N prime is greater than N. So I can give out the expression here. N prime is equal to V divided by V minus of Vs into N. And in the note, I can write the apparent frequency is greater than actual frequency. Apparent frequency is greater than actual frequency. This is the seventh case. So in the seventh case, listener is at rest. Listener is at rest. Source is moving towards the listener. So Vs is positive, VL is 0. By applying the sign convention, I am getting the expression N prime equals V divided by V minus of Vs into N. So apparent frequency is greater than the actual frequency. Now, we shall go on to the eighth case. Listener is at rest as it is, but the source is moving. Instead of towards, I am taking away from the listener. Source is moving away from the listener. away from the listener. So in this diagram, what will happen? The source will be moving away from the listener. Moving away from the listener. This is the direction of propagation of sound wave. Listener is at rest. So velocity of listener is 0. What about the sign convention for Vs? We can say if the propagation of sound wave is along this direction and source is moving opposite to it, then Vs must be negative. Vs must be negative. So in this general expression, I can say V minus of VL, as VL is 0, it is simply V. V minus of Vs is negative, so minus of minus will become plus. So n prime equals V divided by V plus Vs into n. So n prime is less than n. Why? As I mentioned, 330 plus, if velocity of the source is 30 meter per second, so 360. 330 divided by 360, a denominator is greater than numerator. So obviously n prime will be less than n, because this ratio will be less than 1. So n prime is less than n. So apparent frequency in this particular case is less than actual frequency, and that is the expression n prime equals V divided by V minus of Vs into n. So in the 8th case, listener is at rest, source is moving away from the listener. So the apparent frequency n prime equals V by V minus of Vs into n. Apparent frequency is less than the actual frequency. So we have discussed 8 different cases in Doppler effect by speaking about the positions of the listener and the source. You cannot easily memorize those formulas. That is not possible. If you memorize, there will always be a confusion. So simple idea is keep the general expression n prime equals V minus of VL by V minus of Vs into n in mind, and then apply sign convention. As I mentioned earlier, sign convention is very simple. Consider the direction of propagation of sound as the reference. Now consider the direction of source and the listener. If the source and the listener are moving along the same direction as that of the propagation of sound, then their sign must be taken positive. If the source and the listener are moving opposite to the direction of propagation of sound waves, then Vs and VL must be taken negative. If you apply those sign convention, then you can easily calculate the apparent frequency of the sound listened by the or observed by the listener. So whether the apparent frequency increases or decreases with respect to the actual frequency depends upon the respective cases here, whether the source is moving towards the observer or observer is moving towards the source, etc. We saw all the 8 different cases. We just go through one by one, and you can have the expressions for apparent frequency, and you can conclude what will happen to the apparent, or what will be the apparent frequency when compared to actual frequency. As we have discussed, we brought out a condition that the velocity of the medium is taken to be 0. If suppose air, or if the source is considered here, listener is here, sound waves are propagating along this direction. If direction of wind, I can mark it velocity of wind, Vw, is blowing along the direction of propagation of sound waves, then how will you modify the expression? In the position of V, I can write n prime is equal to V minus of VL divided by V minus of Vs into n. In the position of V, I have to write n prime is equal to V plus Vw minus of VL divided by V plus Vw minus of Vs into n. So what change I have made is, instead of taking the velocity of sound as V alone, I have taken it as V plus Vw, because the wind velocity is taking place, or movement of wind is taking place along the direction of propagation of sound. So they must be taken positive. Why? If you know the basic ideas of trigonometry, you can understand it very clearly. If velocity of sound is along this direction and the wind is blowing along this direction, they make some angle theta, then this velocity of wind can be resolved into 2 components. One is Vw cos theta, this is the horizontal component, and this one is VW sin theta, which is the vertical component. We have to add the component which is present along the direction of velocity of sound. So I can write Vs is nothing but V. So V plus VW cos theta. This is the original velocity. This is the original velocity, V plus VW cos theta. As I have considered the condition, wind is blowing along the same direction as that of propagation of sound waves. Theta is 0 because the two are parallel. The two are parallel. So theta is 0. So it is V plus VW. If the wind velocity is opposite the direction of propagation of sound waves, then the two are at an angle of 180 degree. So theta is 180, cos 180 is minus 1. So velocity will be V minus of VW. So this expression will be changed as V minus of VW, here V minus of VW, when the velocity of wind is opposite to the direction of propagation of sound waves, or otherwise the velocity of the wind is from listener to the source. Velocity of the wind is from the listener to the source. Then the apparent frequency will get the expression V minus of VW minus VL by V minus VW minus Vs into N. This is the expression. This is a simple understanding. You might have experienced it very clearly. Suppose if you are calling some of your friend who is playing in a ground, if wind blows along the direction in which you are producing the sound waves, then that fellow could hear it very clearly and easily. If suppose you are calling your friend, you are shouting at your friend, wind is blowing in a direction opposite to the sound waves produced by you, then what will happen? The sound waves will not reach the listener, means it will not reach your friend, so he could not able to hear you clearly. That is the condition we are explaining here in terms of mathematical expression. Conditions for no Doppler effect. When we will not get any Doppler effect. Under the following circumstances, we won't get any Doppler effect, which means the apparent frequency and the original frequency of the sound waves are the same. First one, when the source and the listener are at rest, then there will be no Doppler effect. If the source, sounding source and the listener are at rest, then there will be no Doppler effect. Second one, when the source and the listener are moving, but the distance between them is constant, which means if one car is chasing the other, one is the source, another one is the listener, right? One is producing honking sound and another one, listener, is listening the sound. If the two cars are moving with the same distance of separation, with the same distance, then there will be no Doppler effect, there will be no apparent frequency. The listener will listen the original frequency of sound waves. And the third one, when the source and the listener are moving in a mutually perpendicular direction. The mutually perpendicular direction. Source is moving along this direction, observer is moving, or listener is moving in a mutually perpendicular direction. In this particular case, there will be no Doppler effect. And finally, if the source is at the center of the circle, and the listener is moving over the circle, then he is at the same distance from the source in all its positions. So the listener will listen the same sound as produced by the source. So apparent frequency and actual frequency of the sounding source are the same. So there are 4 different conditions where you will get no Doppler effect: when the source and the listener are at rest, when the source and the listener are moving but distance between them is constant, when the source and the listener are moving in mutually perpendicular directions, and finally when the source is at the center and the listener is moving along the circle. Then in this case also there will be no Doppler effect. Now we shall speak about the applications of applications of Doppler effect. Applications of Doppler effect. One, we can track the speed of automobiles. Second one, we can track the satellites. Third one, radar. Fourth one, sonar. And there is another one application which is very important but not mentioned in your textbook, which is Doppler scans. Tracking of speed of automobiles is quite simple. You might have seen on the highways that there will be a speed limit mentioned on the side of a road, 80 km per hour or 70 km per hour and so on. And you might have seen the petrol vehicle which is parked beside the road. There will be some policemen. They will be stopping your vehicle and asking you why you came with overspeed or why you crossed the speed limit. How come they measure the speed of your vehicle? It's very simple. They will be having an arrangement, a source, which will be producing electromagnetic waves. These electromagnetic waves will be hitting the vehicle and will be returning back. So if they hit the moving vehicle, then the moving vehicle now acts as the moving source which produces the sound waves. They will be received by the receiver set which they have. There will be apparent shift in the frequency. We can say n prime. They measure a different frequency. Original frequency of the sound waves also is known, but the frequency received by them will be different as you are behaving as a moving source. So they know the value of n, they know the value of n prime, and velocity of sound is also known. Then they can easily calculate the velocity of the source, means velocity of the car, because they are stationary. Velocity of the listener is 0. So they can easily measure with this expression n prime is equal to v divided by v, because the source is moving towards the the listener. So we can say here listener is at rest, source is moving towards the listener, it is moving along the direction of sound wave, so it is positive, so v minus of vs into n. This is the formula which they will use, and from which they will calculate the velocity of the sound waves, or means velocity of the source, which is nothing but the speeding car. So easily they can track the speed of the vehicle and they will put fine. Then second thing, tracking of satellites. Satellites will emit radar waves. As the satellite move away from Earth, the radar waves which are reaching the Earth stations will have lesser frequency. So the apparent frequency is less than that of the original frequency. So there is a frequency shift, n prime. So the original frequency of the waves are known. The apparent shift in the frequency are also measured, from which we can calculate the position, or we can track the satellites, at what location exactly the satellite is. That we can do with the help of Doppler effect. Then radar. Radar here stands for radio detection and ranging. Radio waves will be sent from the transmitting end. They will be hitting the aircrafts or aeroplanes or any moving objects, and then they will return back as weak echo signals, and they will be received by the receiver, and then it will be processed, and they will be measuring the apparent frequency. There will be apparent shift. They will be measuring the apparent frequency. As they know the apparent frequency and transmitted frequency, they can easily calculate the speed of the aircrafts or aeroplanes and also their locations. That can be done with the help of radar. And then sonar. Sonar is sound navigation and ranging. It is an acronym for sound navigation and ranging. Sound waves are produced by the devices, and then they will be transmitted into the water or in ocean. They will hit the submarines or any marine animals, and they will return back, and they will come up with a different frequency. We call it apparent frequency. There is an apparent shift. So with the apparent frequency and original frequency, they will be easily calculating the speed of submarines, as well as the location of submarines, as well as marine animals. That can be done with the help of sonar. Along with that, we can also know about Doppler scans. Doppler scans are very important in our day-to-day life. They used to scan out the flow of blood in our blood vessels, Also, we can easily identify the thickness of arteries and veins. That can be done with the help of Doppler scans. They will be transmitting ultrasound signals, and then they will be receiving it at different frequencies. With the difference in frequencies, they can easily calculate the velocity of blood flow in our veins. But thing is that the formula used in Doppler scans or in the measurement of velocity of the flow of blood is different. So up to this lesson is over. You have to go through each and every part of every little bit of the information what we have discussed so far, and can understand what are the things given in that. If any doubts are there, we can have clarifications in later sessions or in our direct classes. Thank you.